All right, good morning or good day, and welcome to this lesson on the introduction of trigonometry. Um, this is the first, maybe your first introduction to trigonometry, and so we're going to start with just some of the basic terminology and labeling the triangles, and then we'll get into the ratios associated with trigonometry. So trigonometry, and for most part, we refer to trigonometry as just trig. You'll hear me say trig all the time as opposed to trigonometry. It's just a simpler way of doing it. And it refers to right triangles. This is really important. I'm underlining this like multiple times because it's really important to understand just right triangles. It doesn't work with every triangle, only right triangles. Most of you are probably familiar with what right triangles means, but essentially right triangle is a 90-degree triangle. Oh, or not sure why, but my screen jumped on me there. So I'm going to jump back up here and hopefully it doesn't do that again, whereby which we're dealing with them and we're finding the lengths of the sides of the right triangle and all the other angles. Of course, we're going to know one angle is going to be 90 degrees. So for basic trig, to work, all triangles must be 90 degrees. So we cannot use this with just any size triangle. We do, just as a side note, not that we're going to do that in this course because we're just looking at the basics, but there is ways to expand trigonometry and use it for things that are not right triangles, okay? But for right now, really important to understand right triangles only, okay? So one of the things we'll do here is we're going to scroll down and look at this diagram of a right triangle, okay? We know it's a right triangle because of this little symbol right here, okay? Tells us it's a right angle right here, okay? And sometimes instead of the word angle, I use this symbol, okay? So if you see me use this symbol where I go like this, and then that's just a symbol for angle, okay? And I'm just going to erase this here. So that is my right angle. And always straight across from here is the hypotenuse. Sometimes I can use the word opposite, but I'm not going to use the word opposite. I'm going to use the word across. So the hypotenuse side is across from the right angle. And I'll use the symbol angle. Okay, so I kind of draw like a symbol like that. Okay, then once we've done that, we have to select something called an angle, and I refer to it as our reference angle. So reference angle. Now, this angle can be either of the two other angles. It cannot be the right angle. Okay, so not the right angle. Okay, that's not possible. We can't do that. But I could have it up here, and almost always we use this symbol called theta. Okay, so if I write the word theta here, that's how they pronounce it, theta. It's a Greek symbol. Okay, don't ask me why, but it's just like mathematicians' favorite symbol for angles is theta, and it's basically a O with a line through it. Okay, this particular one that they're showing here doesn't quite show the line going all the way through, but there sometimes you see it written like this, and the line is on a 45-degree angle, whatever. It's all the same. It's theta. Okay. And that is our reference angle. And once we have decided on our reference angle, and by the way, it could be this one, it could be this one. It's up to us to choose, okay? In this particular case, the author of this particular diagram has chosen the reference angle to be here. And once they do that, you have two other sides that can be labeled. If it is attached or part of the hypotenuse, which it will always be, and this angle, then it's called the adjacent, okay? So it is, adjacent means beside or alongside, side. Made a mistake there. Let me just erase that for a second. Eraser didn't turn on. Let me just get that turned on. There we go. Back to my pen. Alongside theta. okay? So it has to be part of what makes the angle for theta, beside or alongside theta. And then we have one more angle, or one more side, I apologize, is referred to as the opposite side. And it is across from theta. Across from theta, okay? Just like the hypotenuse is across from the right angle, the opposite side is across from theta. Okay. Now, of course, mathematicians are extremely lazy. They don't write out the word hypotenuse, opposite, and adjacent. They use three letters, H for capital H, capital O, and capital A. The one that's a little bit tricky sometimes is the O because it could be confused for a zero, but generally speaking, those are the labels that they're going to use, and you're going to see me use them over and over again as we do trigonometry, okay? So there's your hypotenuse, your opposite side, which is across from the theta, and your adjacent, which is alongside or beside the theta. And then, of course, the hypotenuse is across from the right angle. So what we can do is we can create some questions associated with this. So label the hypotenuse, the opposite, and the adjacent for these particular triangles. And I have labeled the angles, at least two of them, the reference angle, theta, and I have labeled the right angle in this particular case, or at least with my pen. It's not the neatest, but it works, okay? So we can always do the hypotenuse because we know that it's opposite, right? This here. So this is my hypotenuse. It's also the longest side. The hypotenuse is always the longest side, although I don't always like that because it sometimes can be deceptive, but that's the case. Once I've got the hypotenuse, I only have two sides left. I have one here on this side, and I have this side here. Well, this one is beside the theta. This one is opposite. So this is my opposite, and this is my adjacent. Okay. Now, not all triangles lay perfectly laid out like this, so I purposely made one here that's kind of not like that. But again, I use the same basic principles. Find my right angle, go across from my right angle, hypotenuse. Then I have two left. One's going to be the opposite, which is straight across. I always like to label it first for some reason from the theta, and then that leaves me with my adjacent here. Pretty straightforward, okay? If I want to go down, I can do another one where, what if I tell you it's a right angle triangle and I give you a couple of sides, okay? I'm just going to erase this over here. It showed up from before. Now I want to label my theta and my right triangle, okay? Well, opposite my hypotenuse is always going to be my right angle. So to label that, I simply put a square box in the corner, okay? And then if this is my opposite, that means my theta has to be across from it. So theta must be here. And although the question doesn't ask me to do it, this becomes obvious that this is my adjacent side. I didn't give you the adjacent side on this particular one. I didn't need to because you were able to calculate theta from here, and then it has to be the other one. Okay. Same thing with this one here on the bottom. I'll scroll down just a little bit, just makes it easier for me to write. I didn't give you the hypotenuse, but it's obvious if this is the opposite and this is the adjacent, this must be the hypotenuse. And that, therefore, across from the hypotenuse is the right triangle, okay? And then I can now determine where theta is simply because one is opposite of one and adjacent to this one. Adjacent would make it here, that angle, and opposite across. So my theta goes here. And that is my two examples. There's a little worksheet, a few triangles for you to label, and that's it for today's lesson on the introduction of trigonometry. Starting tomorrow, we'll start looking at the ratios, and I believe we'll start with the tan ratio, and then the next lesson will be on the sine and cosine ratio. And for the first time in your life, you'll probably get to use your calculator, which has these tan, sine, and cos functions on it. All right, that's the lesson for today.